So in the diagram, the point M is the center of the circle having Pn as its diameter. KL is a tangent to the circle at N. And this is the nice sketch which we are given, which is fine. Now let's look at the first question. Well, the first question says, please calculate the coordinates of the point P. So we understand that the point P is just another point on the circumference of a circle. But the most important thing is the line PN is the diameter connecting P to N. So if PN is the diameter, then it means M is the midpoint of this line PN. So we just need to use the concept of the midpoint in order to find the coordinates of P. So let's go ahead and do that. Okay, fine. So this is how we say, well, since we are given the coordinates of the point M, then we are simply going to say, okay, the x coordinate at M has to be equal to the x coordinate at P plus the x coordinate at N. And of course, we divide this by 2 because we are already given the coordinates of the center. So we are just going to separate the x's as well as the y's. And of course, we'll do the same for y. So we say the y coordinate at the center is actually equal to the y coordinate at N plus the y coordinate at P. And we say everything is divided by 2 like that. So now what is the x coordinate at M? Well, it's 3. The x coordinate at P is the one we are looking for. And the x coordinate at N, it's positive 7. And of course, we divide this by a nice 2 there. And in order to solve for the x value at P, we are just going to cross multiply. So on the left-hand side, we have x value at P plus 7. On the right-hand side, we have 6. So this means the x value at P is just going to be -1. Okay, fine. Now, similarly, the y coordinate at the center is -5. The y coordinate at N is -2. And y coordinate at P is the one we are looking for. And of course, we divide this by 2. And then once again, we cross multiply. So on the left-hand side, we get -2 plus y value at P. And this is equal to -10. So this means the y value at P is just going to be -8. So what? So this means the coordinates of the point P are simply -1 and -8. So we can simply label them on the sketch, and yeah, that should be that. So now if we look at the next one, they say to us, please determine the equation of a circle in the form x minus a squared plus y minus b squared equals r squared. So find it in center form, right? Okay, fine. So the question is, how are we going to find it? Well, we already know the coordinates of the center, and we also know the coordinates of the point N. So we just need to find the length of the radius, which is Mn. In fact, We don't need to find the radius itself. We just need to find the square of the radius, and that will be enough. So let's just go ahead and do that. Okay, fine. So we can simply find the length of mn squared. And in order for us to find mn squared, we take the x value at n, we say minus the x value at m. Of course, we square this. We take the y value at n, and then we say minus the y value at m. And we also square it as well. Then we say 7 minus 3, but it's just going to be 4. And 4 squared is 16. Negative times negative 5, it's positive 5. And negative 2 plus 5, it's 3. And 3 squared is 9. So if you say 16 plus 9, well, you simply get 25, which means your r squared is just going to be 25. So now we can go ahead and find the equation. So this is what we will say, all right? Cos everything is equal to r squared. We have x here, we have y there. And here we can see that the x value of the center is positive 3. But when we write it into the equation, we say it's negative 3. The y-coordinate of the center is negative 5. But when we write it into the equation, we are simply going to say it's positive 5. So this is the equation of the circle in center form. So the next one says, please determine the equation of the tangent KL in the form y equals mx plus c. Okay, fine. And this is for 5 marks. So we know that a tangent is just a straight line. And just like any straight line, we need to know the gradient of this tangent. But then since we can't find the gradient directly, we need to rely on the radius or the diameter if you like. So we find the gradient of the radius because we understand that the radius is perpendicular to the tangent. And if two lines are perpendicular to each other, we understand that if you multiply their gradients together, the answer will give you -1. So that's the principle we are going to use in order to find the equation of KL. And the point of tangency is already given to us, so it's very nice in this case. So how do we begin? Well, by finding the gradient of the radius, mn. Or you can find the gradient of mp, or you can find the gradient of the diameter itself, which is pn. So it's up to you which one you choose. So let's find the gradient of mn. So we take the y value at n minus the y value at m, and we say this is divided by the x value at n minus the x value at m, all right? Then in the numerator, we get -2 plus 5, which is +3. And in the denominator, we simply get a 4. So it means the gradient of the radius is just going to be 3/4. Well, that's fine. But now, since we understand that if we take the gradient of the tangent, well, the point is supposed to be k, and then we multiply it by the gradient of the radius, the answer has to give us -1. But the question is, what is the gradient of KL? Well, it's the one we are looking for. And what is the gradient of the radius? Well, it's 3/4. And the product must give us -1. So now we need to divide both sides by 3/4, all right? So when we say -1 divided by 3/4, then we find that the gradient of KL is just going to be -4 divided by 3. So now we know the gradient of a tangent. Then we can easily go to our slope point form. That's the name of this equation. And then we say, well, our y1 is going to be -2. But since negative into -2 gives us a positive, we can stop fooling around already and just write it as y plus 2. And our x1 is just going to be 7. And we take these 2 to the right-hand side. It becomes negative. And here we distribute our -4/3. So we get -4/3x plus 4 times 7. Well, 7 by 2 is 14, so by 4, it's 28/3. And of course, we have to say -2, right? And if we go to our very nice and beautiful calculators, and we type in 28/3 minus 2, we find that the y-intercept is just going to be 22/3. So what do you see here? It's just the equation of a tangent KL. And that should be it. So next they say to us, for which values of k will the straight line y equals -4/3x plus k be a secant to the circle? And this is for 4 marks. Now, what is the question looking for? What is k? What is the name of this k? Well, k is the y-intercept. And if you look at this straight line, it has exactly the same gradient as the tangent. Do you see that? So we are looking for the values of the y-intercept such that a straight line that has the same gradient as the tangent will be a secant to the circle. And of course, by a secant, we understand that it's a straight line that cuts the circle at 2 different points. Right. So let's go and destroy it. Well, this is what I want you to do because you need to understand what is a secant, right? But I want to show you something as well. If we draw a straight line here, having exactly the same gradient as a tangent, and in fact, it's going to be a tangent as well, right? Okay, fine. However, if we draw a straight line here, another straight line there, as many straight lines as we like, all of these straight lines are going to be secants to this circle, because it is very clear that each line is going to cut the circle at two different points. However, if you were to draw a line somewhere here, it's not going to touch the circle at all, nor will it cut the circle, right? The same applies if you were to draw a straight line here, having the same gradient, of course. It's also not going to touch or to cut the circle. So this means in order for us to have a secant to this circle, that's if we have straight lines that are between these two tangents. Or maybe I can just do this. Because if you look at all the red straight lines, they are actually between those two tangents. So what we need to do here really is just to find the y-intercept of this straight line that is also a tangent to the circle. And then the values of k will be between the y-intercept of this straight line as well as the y-intercept of that straight line. So let's find the equation of this circle. In fact, tangent, sorry. So this is us. Well, we know the gradient already. So it's just going to be y equals negative 4 over 3x. And then maybe we can say plus c. And then we substitute the point P. So we say negative 1 as well as negative 8. Okay. So if you multiply those two, you get positive 4 over 3. But then you need to take it to the left. So it still becomes negative. So it means the y-intercept of the second tangent is just going to be negative 28 over 3. So what are we saying? These are the values of k. These are the values of the y-intercept such that a straight line drawn on this circle will be a secant. I don't know. I feel like I'm now taking out the niceness of this problem, but I really tried to explain it as nicely as I could. Yeah, anything I'm saying now, it's just, I don't know it's what, but yeah. No, that is what you're supposed to say. So yeah, what is a secant? It cuts the circle at two different points. Okay, fine. So since you understand that we have two tangents touching this circle, but then if you were to say anywhere beyond the two tangents, you can see that those lines will not touch or cut the circle. They can only do so between these two tangents, right? So we just need to find the y-intercept of this tangent and the y-intercept of that tangent. And the value of k, which is a y-intercept, will have to be between those two y-intercepts. Think of it. When the y-intercept is 5 maybe, or when the y-intercept is 10 maybe, or when the y-intercept is 0 there, or when the y-intercept is something, oh no, it can't be 0. What am I saying? That's the x-intercept. But yeah, when the y-intercept is somewhere there, these straight lines are going to be secants to your circle. That is the meaning of this problem. So, well, here they say to us, the points A and B are not shown on the diagram. But listen to what they say. They say the point A is going to have the same X value as the Y value. So maybe 1 and 1, 2 and 2, 3 and 3, and so forth. Or -3, -3. But the values must be exactly the same. So these 2 points are not shown on the diagram. But this is what they say. From the point A, another tangent is drawn to touch the circle with center M at B. And they say, show that the length of the tangent AB is given by this formula or that expression, if you like. Now they want you to visualize things. Guys, it's very important in the exam to make your own sketches. It's useful. Very much useful. Okay, let's look at the statement again. This is what they say. They say from point A, another tangent is drawn to touch the circle with center M at B. So we don't know where A is. We also don't know where B is. But one thing we know about A is that it's either in the third quadrant or the first quadrant, because that's where both of these values are the same, both the X and the Y values, right? And we also don't know where B is. So where are we going to put this tangent? Well, maybe we can just try and say it's in the first quadrant because we don't know where, right? So let's say the point A is somewhere there. And maybe let's say the point B is going to be somewhere there. Maybe let's say this is what we will have. So let's say, yeah, let's say that because we don't know exactly what is happening. So yeah, this is point A and this one is point B. The coordinates are X and Y. They are unknown. So they say, show that the length of the tangent AB is given by the formula that. Okay. 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 Now let's think. Let's think